Hey guys, thanks for taking a second to watch this. This video is going to be about balancing, and if you're watching it, it means that my wife has given birth, and I am not right here right now. I'm actually recording this pretty far ahead of time. It is currently January 5th. For some of you guys, this is the second day that you ever met me, is when this is being recorded. I knew I wanted to teach you balancing because I think it's something you can handle on your own, and I think it's something that's kind of self-contained. So here's the whole point behind balancing. Matter cannot be created or destroyed. So whatever I start with when I start a chemical reaction has to be there at the end in some way, shape, or form or another. It can be transformed, but the same elements have to be there. So I would, because I have also taught biology in the past, think about biology. A long time ago, you learned that photosynthesis equation where it is glucose plus oxygen gives you CO2 and water. The C in CO2 stood for carbon, and it got that from the glucose, which was C6H12O6. The carbon was not created or destroyed. It was just rearranged. It was taken from glucose and put into carbon dioxide. All right? The hydrogens in glucose were rearranged and put into water, okay? H2O. So the whole point is that matter can't be created or destroyed. So let me show you what I'm talking about, and we'll run through a few example problems. Here we go.
All right, so I have a sample balancing problem up over here. We got CH4 plus O2 gives you CO2 and H2O. And I made each one of those chemicals over here. And what you should be noticing is a few things. The colors represent a certain element. So over here I have 4 yellow spheres, so that is the hydrogen, the H. I have 1 black sphere, that's the carbon. I have 2 red spheres, so those are oxygen, red is for oxygen. Over here I got a black one for carbon and the 2 red ones for oxygen. And over here I got a red one for oxygen and 2 yellow ones for hydrogen. So remember what I said earlier, matter can't be created or destroyed. It can only be changed and morphed around. So if I look here, I have a carbon, and then it goes through a chemical process, that's what this arrow means, and we end with 1 carbon. So that's fine, no big deal. But what might stand out to you as being kind of a big deal is I start with 4 yellow spheres for hydrogen, and I only end with 2 after this chemical process has gone through. That doesn't make any sense. I destroyed 2 hydrogens. I can't destroy matter. The same thing is true with the oxygens. I start with 2 and I end with 3. So that's not possible either. So something went wrong. And what we are going to do is we're going to fix that problem by balancing the equation. We're going to put numbers here, and those numbers means that we're going to add additional of these items to make it so that matter is not created or destroyed. Let me show you what I mean. All right, so as I said earlier, I have 2 issues with this. The first is that I start with 2 oxygens and I end with 3. And then the second is that I start with 4 hydrogens, the yellow ones, and I only end with 2, which means I destroyed matter, which is not possible. Matter cannot be created or destroyed. So how do we fix this problem? Because right now it's violating the laws of nature. Well, what we would need to do to fix one of those problems, if I was to focus on the hydrogen problem, where I had 4 and went to 2, is I can add another water molecule. And I would represent that by putting a 2 over here, showing that I have 2 water molecules, H2O. Now the hydrogens are accounted for. I have 4 over here, and I have 4 over here. But I still haven't fixed the problem where I have 2 oxygens here, and now I actually made the problem worse. Now I have 4 oxygens. I created some oxygens out of thin air. So I got to fix that problem. So how do you think, based on what I just did, you might be able to fix that problem? Try it out, and let's see if we agree. Okay, so if you said you needed to add something to this side, you are right. Like we said before, 2 red oxygens here, but now I have 4 over here. So I need to fix that problem. I'm going to fix that problem by adding in another O2 molecule. And I would express that by writing a 2 right here like this. All right? Now, I'm going to check and I'm going to make sure that everything is balanced in this equation. I have 1 black carbon, and I have 1 black carbon. All I'm doing is I'm comparing the left side to the right side and seeing if matter is being created or destroyed or if everything is equal. It's called balancing because you want to make it equal. All right? I have 4 yellow hydrogens, and on the other side, I have 4 yellow hydrogens. Cool. I have 4 red oxygens, and over here I have 1, 2, 3, 4 red oxygens. Yes, they're in different chemicals, but again, all we're doing is comparing the left side to the right side. And so now the whole thing is balanced and the problem is done. Matter hasn't been created or destroyed. What is on the left is equal to what's on the right. The fancy way of saying that in chemistry is that the reactants, the amount of reactants we put in is going to be equal to the amount of products we put in. The elements are not changing. All right? So now that we've done this, and I've shown you how to do it with the chemicals, let's try just kind of more pen and paper, which is what we're going to do a little bit more.
All right, guys, so here's the balancing problem that we just did, except it's without the actual chemicals themselves. It's just on paper. Let's do another one over here. All right? Number 3. I have 1Al, and by the way, I'm going to do this kind of with you. As you can see, these are blank. I have not done these before. I'm going to figure them out with you. And it's also worth noting that I am doing this with pencil. And the reason why I'm doing it with pencil is because I make mistakes, just like you're bound to make mistakes. And I would suggest that you do it in pencil too, because you can just erase it and move on. If you do it in pen, you're bound to have more problems. So the whole point that I'm trying to make is, if you don't get it right the first shot, that's fine. Just keep going. Just keep trying. And that's just a good life skill to have in the first place. All right, so I got 1Al over here. All right, well, I got 1Al on the left side. Let's look on the right side of the arrow. I got 2 over here. That's no good. I created matter. I accidentally created another Al. So how do I fix that? Well, I could put a 2 here, meaning I have 2 aluminums on this side, and I have 2 aluminums on that side. Cool. Over here, I got 2 oxygens over here, and I got 3 oxygens over here. Oh, actually, you know what? I can't really fix this problem as it is. If I put a 2 here, then 2 times 2 is 4, and I'll have 4 oxygens. If I put a 2 here, actually, you know what? That might solve my problem. If I put a 2 here, now I have 2 times 3 is 6 oxygens. And if I put a 3 here, now I have 3 times 2 is 6 oxygens. Hey, congratulations. It looks like it's done. But wait, it isn't. All right? And again, this isn't planned. I just happen to be lucky here. Let's think about this. How many aluminums do I have now because I put that 2 there? I have 2 times 2 is 4 aluminums. That's not right. So I got to fix that. I got to put a 4 there so it equals the 4 aluminums that I have over here. So again, use your pencils because you're bound to make mistakes. I make mistakes. Things change in the process as you do this. That's totally fine and totally okay. All right, so now let's check it out. 4 aluminums, 2 times 2 is 4 aluminums. 3 times 2 is 6 oxygens. 2 times 3 is 6 oxygens. Hey, we're done. We did it correctly. It's balanced. I always kind of like doing this sort of stuff because there is a right answer. You just have to find it. It's kind of like a little logic puzzle. So I actually kind of always like balancing. All right, next problem. We're going to do number 5. You might notice on your worksheet that you might see things like G's and L's. And you might be like, what does that mean? This is just saying state of matter. So this is saying, hey, it's carbon monoxide gas. This is hydrogen gas. And whatever this compound is, it's a liquid, L for liquid. All right, so it doesn't matter towards balancing at all. All right, so again, haven't done this before. Let's see how we do. I got, here's the process that I used to work through this.
And if I'm going too fast for you, you know, rewind me and slow me down and listen to this multiple times. I pick a certain element that doesn't show up very often in here. So for instance, in this problem, a good example of that would be carbon, because it only shows up once on the left-hand side and once on the right-hand side. A bad example of this would be something like hydrogen, because hydrogen shows up here and here and here. So it wouldn't be a good one to start with because you're trying to change too many things at once. But carbon is a great one to start with. So I got 1 carbon, 8 carbons. Any idea what we put here? If you said 8, you are right. Or at least for now, until we go on. We'll see if you're right after overall. All right. Now, and this is just kind of how I personally do it, I look at what that affects. So I affected the number of oxygens by doing that, and oxygen is nowhere else on the left-hand side. So I'm going to say, all right, I got 8 oxygens. How many oxygens over here? Well, I got 8. I should have 8. So 1 times 8 gives me 8. So I've solved the carbon problem, 8 carbons, 8 carbons. I've solved the oxygen problem. I got 8 oxygens and 8 oxygens. But I got a hydrogen problem. So let's fix that problem. I have 2 hydrogens over here and so many hydrogens over here. Remember, it's the entire left side compared to the entire right side. So the most common mistake I see students make is they'll just look and they'll be like, I have 18 hydrogens. But no, you don't. You also have these over here. So make sure you're accounting for everything. Yeah, you have 18, but you actually have 18 plus 8 times 2 hydrogens. So 8 times 2 is 16. So you have 18 plus 16 hydrogens, which is 34 hydrogens. All right. Well, if I have 34 hydrogens on the right-hand side in total, what number could I put here so it'll multiply in, and it'll give me 34 hydrogens in total on the left-hand side? If you said 17, took me a second there to do the math, that is right. Okay? Now this problem is totally balanced. 8 carbons, 8 carbons, 8 oxygens, 8 oxygens, 34 hydrogens, and 34 hydrogens. Okay? Matter hasn't been created or destroyed. Congratulations. All right, I got a bonus problem for you on the backhand side. I created one. All right, here's the one I created. As you can see, this looks much more complicated than what we were dealing with. So I want to show you an example how to do this, so that way when you go do it on your own, you have some idea of what to do. As I said before, pick an element that doesn't show up very often to start with. If you look here, hydrogen shows up here and here and here. That's not a good one to start with. But sulfur just shows up here and here. That might actually be a bit easier to start with. So when I'm doing these sorts of problems, if you can't do everything in your head, sometimes what helps is to go and do like this. I have 1 sulfur on the left, and on the right, I have 2 times 1 sulfurs. All right? They don't equal. So I need to make a change. What change do you think I should make? Well, let's try putting a 2 here. Now I have 2 times 1 gives me 2 total sulfurs. All right? But again, this affected a lot of other things. So let's see what else needs to be changed, if anything at all. Because sometimes you might have a balancing problem where it's already all balanced, and that's totally okay. So 2 times 2 gives me a total of, for hydrogen, it gives me 4 hydrogens, but I also need to account for these hydrogens as well. So I actually have 4, 2 times 2 is 4, plus 4 hydrogens for a total of 8 hydrogens. Again, if I'm going too fast, rewind the tape and try it again and see if it makes more sense. Over here, I only have 2 hydrogens. Well, that's no good. Those don't equal. So what can I do? Well, I could put a 4 here. And if I do that, now I have 8 hydrogens over here. All right, so I fixed the sulfur problem. I fixed the hydrogen problem. If I'm looking at PB, because again, I'm trying to avoid working on the oxygens till the end, because the oxygens show up absolutely everywhere. They show up here and here and here and here. So it's going to be hard to work on that. So instead, I'm going to work on PB, and I'm going to make oxygen the last thing I do, because by doing that, it avoids kind of tripping over yourself. So I got 1 PB, and I got 1 PB. Excellent. Nothing I need to do there. All right, now comes the fun part. Now we get to work on oxygen. All right. Again, going too fast, slow me down so that way you can understand. The number of oxygens I have in total on the left. Don't just pick one chemical. I'm talking about the whole thing. So 2 times 4 gives me 8 total oxygens. 4 times, like an implied 1, because I wrote oxygens, that means I have at least 1. 4 times 1 gives me 4 oxygens. 8 plus 4 is equal to 12. I have 12 total oxygens on the left. Let's see how I'm doing on the right. 2 times 4 gives me 8 total oxygens. And 4 times 1 gives me 4 total oxygens. Put them together and you get 12. And look at this. The number of oxygens, by us saving that till last, worked itself out. Imagine if we had started with that, what a mess this would have been. But because we left it for last, the problem solved itself. Okay? So that is how you would balance that sort of problem. All right? Okay, so hopefully with this sort of thing, you have a better idea on how to balance. If, for whatever reason, this did not work for you, there are tons of balancing tutorial videos on YouTube that I would suggest that you look at. Those would help you out immensely if you need more practice with it. Normally, I'd say I'd help you, but to be honest, I'm probably going to be very preoccupied with the baby in taking care of it, considering I learned the other day that they wake up every 3 hours, so that's fun, especially when it comes time for nighttime. So I hope you do well. I hope you find this enjoyable like I do, and that it's kind of like a cool logic puzzle. And that's that. So, oh, one last quick thing that I want you to understand, because this comes up as well pretty often. This is already balanced. Everything's great with this. But let's say that I put a 2 here. If I was counting, you know what? Let's try something else. Let's say I put a 2 over here. Or you know what? Let's say I put a 3 over here. So it's easier for you to understand. And I just had a question that said, hey, what's the number of oxygens just in this chemical? The way you would figure that out is you would do 2 times 4 is 8 times 3 gives you the number of oxygens. So in this sort of scenario, if I said, hey, what's the number of oxygens in this chemical and this chemical only, and I had a 3 there, you would do 2 times 4 is 8 times 3 is 24. And that would be the answer, okay? So bear that in mind when you're balancing if something has parentheses, okay? All right, that's it. Good luck, guys.